Welcome to Lesson 14 of Ubuntu Mastery, the point where your server stops just blocking and starts thinking. So far, Lesson 12 gave us static UFW rules, and Lesson 13 hardened SSH against bad auth. Now we add the dynamic layer, watching logs, spotting attack patterns, and banning offenders automatically with two complementary tools, fail2ban, the battle-tested classic from 2004, and CrowdSec, the modern crowdsourced engine from 2020. Let's start with fail2ban since it's the foundation. The mental model is just three pieces. A jail says who to watch, a filter is the rejects that recognizes an attack in the logs, and an action is what happens when the trigger fires. Usually a firewall ban for a fixed window that auto-expires. Configuration lives under chash, etc. or fail2ban, and the golden rule is never touch jail.conf. Drop your overrides into jail.d instead. The sshd filter you see at the bottom is the classic example. Any failed password or invalid user line gets its IP extracted through the host capture group, and once max retry is hit within find time, that address goes straight into UFW. Here's what that override actually looks like in practice. Two details matter most on Ubuntu 24.04. Backend must be systemed because there's no auth.log anymore. Fail2ban reads straight from journal, and banaction is UFW, which hooks directly into the firewall you built in Lesson 12, instead of dropping raw iptables rules underneath it. 3 failures in 10 minutes earns a 1-hour ban, and bantime.increment ratchets repeat offenders up to a full day. Don't skip ignore it. List your loopback, your LAN, and your jump host, or you will eventually lock yourself out. Now we step beyond fail2ban to its modern cousin, the key shift. Fail2ban only sees your logs, while CrowdSec pools signals from over 200,000 machines. So when 5 of them get hit by the same brute force pattern, that IP lands on a shared block list and your server blocks it before the first probe ever arrives. Install pulls from CrowdSec's own apt repo because it's fresher than Ubuntu's, and you grab a bouncer alongside the engine. The bouncer is what actually enforces decisions at the firewall. Architecturally, think 3 layers. Parsers extract events from logs, scenarios detect attack patterns, and bouncers apply the bans. Then SysAdmin hub pulls down community collections, SSHD, Nginx, Linux, and sshd metrics, decisions, and alerts are your daily driver. And this is where CrowdSec really earns its keep. The community block list. You enroll your engine with sshd console enroll, then subscribe to lists like Firehole Laspis for known attackers. Notice the asymmetry in the decisions output. Your local engine made 14 bans, but you're pulling nearly 25,000 preemptive bans from the community. And performance holds up because the bouncer uses inevitable sets, the same kernel machinery from Lesson 12, giving you logarithmic lookups even across millions of IPs. One privacy note. Only confirmed attacker IPs are shared, never user traffic. So which one do you actually pick? Both watch logs and ban offenders, but the philosophies diverge. Fail2ban is 20+ years of battle-tested simplicity. Drop in a jail.local. Rejects your logs. Done. CrowdSec is the modern take. Behavioral scenarios. Community intel from 200,000 hosts and inevitable sets that scale into the millions. Rule of thumb, under 5 hosts and you already know fail2ban, stay there. Fleet beyond 5, lean CrowdSec. And on-edge web servers honestly run both. Fail2ban for instant SSH trust, CrowdSec for the community signal on web traffic. And here's exactly how that split works in practice. Step 1. Lock fail2ban down to the SSHD jail only, no Nginx filters, nothing else. Step 2. Let CrowdSec handle the rest with the Nginx, Linux, and base HTTP scenarios collections, then explicitly remove its SSHD collection so you don't get duplicate bans on the same address. The two write through different paths. Fail2ban inserts per IP deny rules into UFW, CrowdSec pushes into an inevitable set, and both stay visible in NFT list rule set from Lesson 12. The golden rule, never point both tools at the same log, or you'll loop yourself into false positive hell. Once both tools are running, don't let those bans just sit in log files. Bans are valuable telemetry. Fail2ban writes to Journal, so Promtail picks it up for free and ships it to Loki from Lesson 11, where a query like unit equals failban.service, filtered for ban, gives you a live event stream. CrowdSec is even friendlier. Flip on its native Prometheus endpoint on port 6060 and scrape CSS active decisions directly. From there, 2 alert rules earn their keep. Attack wave detected when decisions jump by 50 in 5 minutes, and fail2ban, flood of bans when ban rate per host crosses 10. That's when you page someone. Grafana on top gives you the world map, the top offender countries and ban duration histograms. The kind of dashboard that turns a quiet defense into actual situational awareness. Now, what we covered today is genuinely just the fundamentals. Enough to get both tools running and talking to your stack. If you're running this in production across a fleet, each tool has its own 13-lesson mastery course with hands-on labs. The fail2ban track is a classic deep dive, jail.local internals, regex filters with 20 real samples, multi-jail strategy, IPv6, performance at 100,000 plus bans, and a full migration chapter at the end. The CrowdSec track goes modern and community first, writing your own parsers and scenarios, multi-tenant LAPI, CTI and CAPI federation, the AppSec engine, Grafana templates, and the reverse migration playbook from fail2ban. Links are on screen. Pick the one that matches where your infrastructure is heading. Before you go deep, here are 5 gotchas that will bite you in production. Number 1 is the silent killer on 24.04. fail2ban's default backend looks for juch var log.choth.log, which simply doesn't exist anymore. So the jail loads and bans absolutely nothing. Set backend equals systemed and you're back in business. 2, whitelist your CI and bastion IPs in ignore IP before your own pipeline locks itself out. 3, CrowdSec without a bouncer is just an audit log. The engine decides, the bouncer enforces, always install both. 4, never let fail2ban and CrowdSec watch the same log source, or you'll get duplicate ban races. And 5, turn on bantime.increment so repeat offenders escalate from 1 hour up to 24 instead of cycling forever. So let's pull it all together. You now own 6 concrete skills: the jail filter action architecture, a production SSH jail tuned with system backend and incrementing bans, the CrowdSec engine and bouncer pipeline, the community CTI block list that preempts 200,000 known bad hosts, a clean split where fail2ban handles SSH and CrowdSec handles web with no overlap, and finally Journal to Loki, plus the Prometheus endpoint for burst alerts. That's your dynamic layer sitting on top of L12's UFW and L13's hardened SSH. Next up, Lesson 15, sudo, PAM, and sysctl, the privilege boundary and the kernel itself. And that's Lesson 14 in the books. Dynamic blocking is live, layered on top of your firewall and your hardened SSH. Lesson 15 takes us inward. Sudoers files under expectora sudoers.d for least privilege. The PAM stack across auth, account and session, and sysctl knobs for kernel, network, and file system hardening. It's also the bridge into the 13-lesson Linux hardening mastery track. Run next lesson. Start when you're ready. See you in 15.